So this is Dalton's law of partial pressures. In words, it means that in a mixture of gases, the total pressure is the sum of the individual pressures. So if you were to imagine blowing up a balloon, you're exhaling a mixture of gases. It is primarily CO2. There could be some oxygen in there. There could be some nitrogen. There could be trace amounts of other gases. So if you wanted to calculate the pressure, the total pressure inside that balloon, what you would do is add up all the partial pressures that each gas is contributing. And the other part of Dalton's law is that each gas contributes its pressure individually. So they don't all meld together and have the same pressure. Each gas continues to carry its own pressure. And if you want to know the total pressure in a container, you're simply going to add all the pressures of all the partial gases. So if we look at PT stands for the total pressure, you're simply going to add the partial pressure of gas 1 plus gas 2 plus gas 3, and then you can continue to add for as many gases that are in that sample. So you just keep adding and adding until you get all the gases in the sample. The P1 and P2, you'll see down here, could be the partial pressure of gas number 1. If you don't know what that gas is, you can just use a P1. You will see sometimes you can also use pressure and then put the formula of the gas. So if it's CO2, you would write PCO2. You can do it either way. If you know the identity, you can include the formula of the gas or just assign it as this is P1, this is P2, etc. Then the only other thing you got to remember is, because you're dealing with pressure, and pressure has a number of different units, the units of pressure can be any. They can be any of the units. The only thing you have to remember is the units have to be the same. So it could be in atmospheres, it could be in kPa, it could be in torrs, it could be in millimeters of mercury. It doesn't matter as long as the pressure of all the things that you're adding is the same. So we're going to start by doing practice problems here. So it says, what is the partial pressure of hydrogen? So what you're looking for here is the partial pressure of the hydrogen gas and a mixture of gases that contain hydrogen and helium, so only those two gases. If the total pressure of helium is 439 mmHg and the total pressure is 600 mmHg. It can get a little confusing if you don't read this correctly or if you don't read it at all. You're going to see first you have the partial pressure of H2 gas. Remember, hydrogen's a diatomic gas, that's why it would be H2. And then here you could get a little confused with this word total. If you were just trying to pick out the numbers, you may see the total pressure as 439. That is not the total pressure of the mixture, that is the total of just the helium. So that is PHE. And then we have a total pressure PT of 600 millimeters of mercury. So then we simply do our formula, the total pressure. Now I'm going to write these pressures, these partial pressures with the formula. That helps me. Again, if it doesn't help you, you can just assign them as 1 and 2. So now I know that the total pressure is going to equal the partial pressure of hydrogen plus the partial pressure of helium. One thing you have to look at, remember, is the units. They have to match. So the partial pressure of helium is in mmHg. The partial pressure of the total is mmHg, so we're good to go. The units match, so we can just go ahead and plug in our numbers. So PT is going to be 600. pH2 is actually what I'm looking for, so I'm going to put pH2. And then the partial pressure of the helium is 439. So now I'm just going to use my algebra skills, and to get the H2 by itself, I'm going to subtract 439 from both sides. So I will get my partial pressure of helium to be 161, and then remember the units have to match, so my units here are millimeters of mercury, just like the other two. Okay, if we go down to the second one, 3 of the primary components of air are carbon dioxide, nitrogen, and oxygen, so that's what we're dealing with, is those 3 gases. And a sample containing a mixture of only these gases at exactly 1 atm. So it's saying the whole sample is at 1 atmosphere. Another way to say the whole sample is the total. The partial pressures of carbon dioxide and nitrogen, so we know CO2 and N2, are given here. So it literally writes them out for you. What is the partial pressure of the oxygen? So I'm going to show you a different way of solving this. In the top one, it was pretty clear, so I just kind of labeled it as I went. But here I'm actually going to write the knowns on the side. So I'm going to say, okay, I know my total pressure is 1 atm. I know my partial pressure of CO2 is 0.285 torr. My partial pressure of nitrogen is going to be 593 torr. And then I'm solving for the partial pressure of the oxygen. Remember O2 because it's diatomic. I'm going to put a little question mark because that's what I'm solving for. Before I do anything else, I have to take note that the partial pressures are in torr, the total pressure is in atm. And I'm going to remember our rule. They can be in any unit. The rule is just that the unit has to be the same. So I technically could change both of these to ATM. I could change this one to torr. I could change them all to kPa if I wanted to. The easiest way to figure out is what is the easiest method. What should I change? What is the easiest one to change? Well, if I have two that are in torr and only one that is ATM, it's going to be easier just to turn the ATM to torr. Also, the conversion between ATM and torr is very easy. 1 ATM is exactly equal to 760 torr. So that makes things easier. So when you're deciding what unit to put it in, always just go with the easiest thing. You know, go with the one where you only have to convert one, or one where the conversion is very simple. So I'm going to write up my formula again. PT is going to equal PCO2 plus PN2 plus PO2. And then I'm going to go ahead and plug in. So I have 760 equals 0.285 torr plus 593 torr plus what I'm looking for, what I'm solving for is PO2. So I'm going to subtract 0.285 and 593 from both sides. And I'm going to get the value of the partial pressure of oxygen to be 166.19. Remember, my units have to match, so that is in torrs there.